and welcome back. We have been discussing about AI and collaboration in ethics and co-intelligence systems. We further our discussions here. We have been seeing the emergent theories. We have also seen how AI helps in disaster response and humanitarian aid scenario. We have also seen the lacuna or the loopholes. We would now be talking about the emergent behaviors in AI systems. As AI systems grow more complex, certain behaviors may emerge that challenge traditional ethical frameworks. Number one, quasi creativity. Generative AI like OpenAI's GPT models can produce art, poetry, or stories that reflect deep cultural or ethical narratives. Although AI lacks intention, the outputs can provoke ethical debates about originality and authorship. Adaptive responses. AI systems in dynamic environments, example autonomous drones, can exhibit emergent decision-making behaviors based on real-time inputs. These behaviors, while unprogrammed, are constrained by underlying algorithms and remain fundamentally devoid of moral intent. Mimicking empathy, social robots like Sophia and Peppa simulate empathetic interactions, helping in caregiving or therapy. Though effective, their lack of genuine understanding raises concerns about manipulation and dependency. Collaborative models, AI and humans together. Future systems might harness co-intelligence to blend AI's analytical power with human moral depth. HITL, or human in the loop, is a scenario where humans oversee and guide AI in ethically sensitive decisions, ensuring accountability and cultural sensitivity. Medical AI tools that provide recommendations reviewed by physicians is an example. AI augmented ethics panels. AI systems analyze vast ethical literature and paste case studies to support human decision makers in novel scenarios. Example, AI helping policymakers design fair, inclusive AI regulations. Decentralized AI ethics training, involving diverse global communities to shape AI's ethical decision-making frameworks, ensuring cultural diversity. Human-AI collaboration in ethical decision-making combines the complementary strengths of human moral reasoning and AI's computational capabilities. This co-intelligence model is particularly suited to complex ethical dilemmas where both analytical precision and nuanced judgment are essential. Below is an exploration of existing and potential frameworks for such collaborations. Transparency. AI systems must provide clear reasoning for their suggestions or decisions, ensuring that humans can understand and scrutinize the ethical implications. Complementarity. The systems leverage AI's ability to process vast data sheets and identify patterns while leaving moral judgments, cultural sensitivities, and emotional considerations to humans. Iterative feedback. Continuous interaction between human and AI agents ensure decisions evolve and adapt to changing contexts and values. Examples of human-AI co-intelligence in action: healthcare, AI-assisted diagnosis and treatment collaborative model. AI systems analyze patient data to recommend diagnosis or treatments. Human physicians review and contextualize these recommendations, ensuring they align with ethical standards like patient autonomy and equity. Example, IBM Watson Health provides treatment options, but doctors make the final decisions based on patient scientific circumstances. Ethical strength. The combined system reduces errors and ensures decisions consider both methical and personal ethics. Disaster response, collaborative model. AI analyzes real-time data, example satellite images, to prioritize regions needing urgent humanitarian aid. Human decision-making incorporates local knowledge and cultural context to guide the distribution of resources. Example, AI systems deployed during the Nepal earthquake in 2015 identified damaged areas faster than human teams alone. Ethical strength, it combines speed and objectivity with human empathy and cultural awareness, minimizing harm while respecting local norms. Corporate ethics and fairness, collaborative model. AI audits hiring practices or pricing models for bias, while human ethic panels review the findings and make corrective policy decisions. AI tools that evaluate job applicant data to ensure diverse and fair hiring practices are reviewed by HR professionals for ethical alignment. The ethical strength, it ensures objectivity while avoiding over-reliance on potentially biased algorithms. Frameworks for co-intelligence models, human in the loop or HITL systems. Humans actively participate in the decision-making process, providing oversight and approval of AI-driven outcomes. Use case, autonomous drones in military operations require human authorization for lethal actions. Humans monitor AI decisions but intervene only when necessary. Use case, financial trading systems where AI executes trades but humans oversee ethical compliance with regulations. AI operates autonomously with humans involved only in initial training and design. Less suited for ethical dilemmas but relevant for automated processes like routine manufacturing. Potential challenges in collaboration, however, are number one, over-reliance on AI. Humans may defer too much authority to AI, risking ethical blind spots. AI's lack of moral understanding. AI cannot genuinely comprehend values like justice, compassion, or fairness, requiring humans to translate these concepts into actionable rules. Number three, bias in collaboration. AI systems may introduce or amplify biases in human AI decisions if their training data or algorithms are flawed. 4. Responsibility and accountability. Collaborative systems complicate questions of liability. Who is accountable for ethical failures? The human operator, the AI developer, or both? Future directions. Dynamic ethical AI framework. AI systems could incorporate diverse ethical theories and adapt decisions based on user input and evolving societal norms. Example, AI in healthcare could prioritize different principles. Example, equality versus need based on stakeholder preferences. Global co-intelligence networks. Collaborative networks where humans and AI across the globe work together on shared ethical challenges such as climate change or global health crisis. Ethics education for AI developers. Training developers in moral philosophy and ethics, ensuring the systems they design reflect human values. That also should be made compulsory. Universities could introduce mandatory ethics modules in AI and computer science programs. Multicultural AI design. Embedding diverse cultural and ethical perspectives into AI training data ensures decisions respect global values and avoid cultural imperialism. So what is the takeaway here? Human-AI collaboration in ethical decision-making thrives on complementarity, while AI augmenting human abilities rather than replacing them. By blending computational precision with human blending, human judgment, these systems can tackle ethical challenges more effectively than either could alone. However, robust safeguards and frameworks are essential to ensure these collaborations uphold shared human values. Now, the question that we are interested in is which specific collaborative framework or a real-world case study would all of us like to explore. Some of the suggestions are again the human in the loop HITL in healthcare, a case study of AI-assisted cancer diagnosis and treatment recommendations. Human on the loop HOTL in disaster response, how AI helped coordinate humanitarian aid during the 2015 Nepal earthquake. So HITL, human in the loop, and HOTL, human on the loop, are both significant. HITL, ethics in autonomous vehicles, the use of simulation testing for ethical dilemmas in self-driving car technology. AI and fairness in hiring practices, a case study on AI systems like biometrics and how human oversight improves fairness in recruitment. Dynamic ethical frameworks in AI for complete change. Examples of human-AI collaboration in creating ethical solutions for environmental sustainability. AI is increasingly being deployed to address the multifaceted ethical challenges posed by climate change, such as balancing environmental sustainability with economic and social equity. Below is a detailed exploration of how human-AI collaboration in this area works, highlighting dynamic ethical frameworks and real-world examples. Role of AI in climate change solutions. AI contributes to climate change solutions by modeling and prediction. Now, what is modeling and prediction? Modeling and prediction is identifying patterns in climate data to forecast impacts, example, rising sea levels, extreme weather events, and so on. Resource optimization, helping industries reduce waste and improve energy efficiency. Policy design, supporting decision makers in crafting equitable and effective climate policies. However, these applications raise ethical concerns including fairness, inclusivity, and unintended consequences. Dynamic ethical frameworks in AI systems. AI systems often prioritize outcomes without fully considering the ethical implications of the means used to achieve them. Dynamic frameworks must balance utilitarian goals, minimizing harm, with deontological principles, respecting rights and justice. Frameworks incorporate input from marginalized communities disproportionately affected by climate change, ensuring AI decisions reflect global equity. Balancing short-term versus long-term goals. AI optimizes solutions for both immediate relief and sustainable strategies for future generations. Real-world case studies. Case study 1, Project Drawdown. Objective was using AI to identify and prioritize the most effective strategies for reducing greenhouse gases. Collaborative framework. AI analyzes data on renewable energy, agricultural practices, and industrial processes to identify high-impact solutions. Human experts validate and refine these strategies, ensuring cultural and socioeconomic considerations are integrated. Ethical challenges addressed. equity in resource allocation, example, ensuring developing countries benefit from renewable technologies, balancing economic growth with environmental preservation. Case study 2, Microsoft's AI for Earth initiative. Objective was providing AI tools to researchers and organizations working on climate sustainability. The collaborative framework, AI models predict deforestation, optimize water use in agriculture, and monitor biodiversity. Human scientists ensure AI recommendations align with local environmental needs and ethical norms. Ethical challenges addressed. Mitigating the environmental impact of AI's computational demands, involving indigenous communities in land use decisions. Case study 3, Climate Change Policy Simulation. Objective was to help policymakers simulate the outcomes of proposed climate policies. Collaborative framework, AI simulates global temperature and emission trajectories based on various policy scenarios. Human policy makers analyze these simulations to craft equitable strategies that address economic and social disparities. Ethical challenges addressed, bridging the gap between developed and developing nations in emission responsibilities, ensuring policies consider vulnerable populations. Ethical challenges in AI for climate change, algorithmic bias. AI models trained on historical data may perpetuate inequities such as prioritizing wealthy nations' needs over those of poorer regions. Environmental costs of AI. Training large AI models consumes significant energy, potentially undermining environmental goals. Lack of accountability. Decisions influenced by AI can obscure human responsibility, complicating accountability for ethical failures. Exclusion of local knowledge. Over-reliance on AI risks sidelining the lived experiences and wisdom of local communities most affected by climate change. The future directions for dynamic ethical frameworks, AI-empowered participatory decision-making. One can create platforms where AI presents climate scenarios and local stakeholders provide input to co-create solutions. Example, community-driven AI models for flood risk management in vulnerable coastal areas. Ethical AI energy use, developing low-energy AI algorithms to ensure the tools themselves are environmentally sustainable. Multi-criteria optimization, AI systems that balance environmental, social, and economic priorities rather than optimizing for a single metric. Cross-cultural ethical frameworks incorporate diverse cultural values into AI training, ensuring globally equitable outcomes. So, we see that the dynamic ethical frameworks in human-AI collaboration for climate change ensure solutions are not only effective, but also equitable, inclusive, and sustainable. By integrating AI's analytical power with human wisdom and moral reasoning, these frameworks address the complex ethical dimensions of climate action. The future frameworks for ethical AI collaborations in climate change would be to address the evolving challenges of climate change ethically and equitably. Future frameworks for human AI collaboration need to be dynamic, inclusive, and adaptable. Now, if we are to talk about some of the key principles for future frameworks, we can perhaps talk about holistic integrations of ethics, which is embedded ethical considerations at every stage of AI development and deployment, from data collection to implementation, could be one of the key principles for future framework. Addressing competing ethical priorities such as economic growth versus ecological sustainability within the system design. Global equality, ensuring that benefits and responsibilities for climate action are distributed fairly across developed and developing nations, including marginalized and vulnerable communities in decision making. Sustainability of AI systems, develop energy efficient AI models to minimize their carbon footprint, using renewable energy sources for powering AI infrastructures, transparency and accountability, maintaining clear records of AI decision-making processes, assign responsibility for ethical lapses to ensure accountability in collaborative systems, cultural sensitivity, incorporating diverse cultural and indigenous knowledge into AI training, data, and decision frameworks. Framework components, participatory AI design. AI tools are co-designed with input from stakeholders at all levels, including local communities, policymakers, scientists, and ethicists. Implementation use workshops, surveys, and focus groups to identify community needs. Develop customizable AI models tailored to local conditions and values. Ethical AI evaluation boards. The concept is to establish interdisciplinary boards to oversee AI projects in climate change, ensuring alignment with ethical standards. The roles could be to review AI algorithms for biases and inclusivity, to evaluate the environment and social impact of proposed AI solutions. Dynamic policy simulation platforms concept, which is an attempt for interactive platforms powered by AI to allow policymakers to explore the outcomes of various climate strategies before implementation. The features incorporate real-time data on emissions, economic trends, and social impacts. Provide scenario analysis to weigh ethical trade-offs, example, short-term sacrifices or long-term goals. Features, it incorporates real-time data on emissions, economic trends, and social impacts. Provides scenario analysis to weigh ethical trade-offs. Emerging technologies in future framework, federated learning for decentralized data. A machine learning approach where data stays localized and only model updates are shared. Use case, collaborating with countries or communities reluctant to share sensitive environmental data while ensuring AI systems learn from diverse data sheets. AI ethics sandbox for climate innovation concept is to create virtual environments where AI models can be tested for ethical compliance in simulated climate scenarios that would identify potential biases or harmful consequences before deployment. It would definitely encourage experimentation with new ethical frameworks in low-risk settings. Example of a future framework would be the Global AI Ethics for Climatic Change Alliance, which is popularly called as GAECCA, or again Global AI Ethics for Climatic Change Allowance. The vision has been a worldwide collaborative initiative where nations, corporations, NGOs, and local communities work together to ensure AI-driven climate solutions are equitable, ethical, and effective. Key features: ethical guidelines to develop a globally accepted code of ethics for climate AI, balancing universal principles with regional adaptations. AI sharing platform provide open access tools and data sheets to democratize AI innovation for solutions. However, if we see the challenges and mitigation strategies, we would see that the first, balancing ethical complexity with practicality. Mitigation use dynamic multi-criteria optimization to balance competing priorities like equity, efficiency, and sustainability. Challenge: overcoming global inequalities. Mitigation provide funding and capacity building for developing nations to access and benefit from advanced AI systems. Challenge ensuring stakeholder participation, mitigation, use digital platforms and local workshops to engage a diverse range of voices even in remote areas. The future vision, ethical AI as a climate ally. Imagine an interconnected global system where AI tools dynamically adapt to local conditions, empowering communities to make informed decisions. Renewable energy powered AI systems operate sustainably, reducing their own environmental impact. Ethical AI collaborates with humans to design policies that save ecosystems, support vulnerable populations, and drive equitable growth. By combining technological innovation with ethical foresight, these frameworks could transform AI from a mere tool into a trusted ally in the fight against various changes, including climate changes. So, we have been discussing about AI and the ethical concerns. We have also discussed the co-assisted intelligence in our previous lecture. Hopefully, with this about the future vision on ethical AI, we hope that there will be positive changes in the coming times. Thank you so much.